Hello, my name is Julian, and today we will be doing a proof together. We will be proving that an equilateral quadrilateral is a parallelogram. The first thing I have to do is to write my given and proof statement. So I wrote that my given statement is quadrilateral, ABCD is equilateral, and that my proof statement is quadrilateral, ABCD is a parallelogram. Before I begin my proof, I also have to draw a diagram. I have to choose an equilateral quadrilateral to work with, so I choose a square, which I already labeled ABCD. Um, um, I also draw lines AB, BC, CD, and AD, so that I can use them later in my proof. So step 1 is that quadrilateral ABCD is equilateral, and my reason for it is that it is given. Pretty simple so far, right? So on step 2 is that segment AB is congruent to segment DC. Also, segment AD is congruent to segment BC, and I know this because of the definition of equilateral. For my third step, I have to draw a diagram, AC. So I give actually a segment from point A to point C. And then once I draw that, I can say that segment AC is congruent to segment AC because of the reflexive property. You see what I got now. So two congruent triangles. Triangles ACD and ACB are congruent because of the side-side touch, or SSS. Now I can use CPCTC to use that angle. BAC and DCA are congruent. In step 6, I can use the alternate interior angle theorem, which says alternate interior angles are congruent if and only if the lines that form them are parallel. Once that, since this is um, a biconditional, I only have to prove that angles BAC and DCA are congruent, which are the alternate interior angles, and automatically lines AB and DC are parallel. For steps 7 and 8, I repeat what I did in steps 5 and 6. I use CPCTC to conclude that angles BAC and ACB must be congruent. And then using the alternate interior angles theorem, the alternate interior angles theorem, I conclude that lines AD and BC must be parallel because the alternate interior angles were congruent. We are almost done. Now we just use the justification that segments of parallel lines are parallel. To say that the opposite segments are parallel, that is, segment AB is parallel to segment DC, and segment AB is parallel to segment BC. Finally, in my last step, I say that quadrilateral ABCD is a parallelogram because the definition of parallelogram states that the opposite sides must be parallel, which we just proved. QED. Thank you for watching my proof. I would appreciate any constructive comments on how to make it better. Goodbye.